Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the October-November 2023 paper 4 Mechanics. This is 4 variant 1 Mechanics from Cambridge 9709. And here we have a diagram showing a particle A of mass 1.2 kilograms, which lies on a plane inclined at an angle of 40 degrees to the horizontal, and a particle B of mass 1.6 kilograms, which lies on a plane inclined at an angle of 50 degrees to the horizontal. The particles are connected by a light inextensible string, which passes over a small smooth pulley P fixed at the top of the planes. The parts AP and BP of the string are taut and parallel to the lines of greatest slope of the respective planes. The two planes are rough, with the same coefficient of friction, mu, between the particles and the planes. Find the value of mu for which the system is in limiting equilibrium. Okay, so now, what we got to do is, I've got a diagram here so that we don't have to keep scrolling up and down and giving ourselves headaches. Okay, I've got here the diagram. So I'm going to draw the forces acting on the diagram. So that's always a good thing, a good way to start. All right. So we'll start off with the weight of the particles acting straight down. Okay, for both of them. So you're going to have the weight, you're going to have the tension in the strings acting this way. You're going to have the reaction forces, which are important in this case because of the frictional force that's going to act. And I'm going to draw in the friction in a minute. Let's just put this. This is 1.6 G down. This is 1.2 G down. This is the reaction at A. This is the tension, okay, which is the same all the way through the string because it's a light inextensible string and there's a smooth pulley. And that's the reaction at B. Okay, those are the forces acting. Now there's one more force, which is a force of friction, okay, because they're rough planes. Okay, now if there was no friction at all, then because this is heavier, it would move down here. That's how it accelerates. So the friction is preventing B from going down and also preventing A from going up. So for B, the friction will be acting in this direction and it's limiting equilibrium. So that's F max. Okay. And for A, it will be acting in this direction. Okay. That will be F max. So this is F max for B and this is F max for A. Now, are they going to be the same? Well, the friction depends on the mu and also the reaction forces, so they might not be the same. They might not be the same, okay, because they depend on the two things. One of them is the reaction force, and the other one is the mu. So so I'm going to label them F max A, F max for A, and F max for B. Okay, so now it's in limiting equilibrium. So let's consider, for example, A first. Let's consider A, right? Let's look at the forces acting on A and resolve them parallel and perpendicular to the plane. So we got this, I'm just going to draw lines here and here just to help us. So we have this angle is 40 degrees because the incline angle and this angle between the weight and the reaction is always going to be the same, and this angle is 50 degrees for that same reason, as I've explained why in many reasons to similarity. Many different videos have explained that already. Now, so if we resolve, for example, A perpendicular to the plane, we can say we have RA is equal to 1.2 G, and here we have to resolve in the direction of the angle into the angle to go this way. Let me just change the color to show that it's a resolve force. So here we have to resolve going into, okay, the angle. So that's going to be using cosine. So that's 1.2 G cosine 40. So RA is equal to 1.2 G times cosine of 40. All right, so that's the reaction force at A. Okay, I'll leave. So that's going to be basically, as we're using G as 10, that's going to be 12 cosine of 40. And I'll leave it like that for now. We can deal with it later, the exact value. And we can also resolve forces going up the plane, in which case we'll have T equals, And we're going to have, if we resolve this force this time, if we resolve this force, this weight, if we resolve the weight perpendicular to the plane or parallel to the plane this time, okay, in this direction, it's going to be 1.2g away from the angle sine 40, 1.2g sine 40. Okay, so that's going to be t equals 1.2g sine 40, but then you're going to have plus F max. Okay, plus F max. Okay, the maximum value of friction. All right, so this is going to be t equals 12 times sine 40 plus F max. Now we know F max is equal to mu r, so we'll leave that because we need to know, we know r, we know F max. We need to find what t is now. Okay, so let's have a look. All right, so remember, we want to find mu, and we know that mu is equal to F max over r. So if I can find F max and r, I can find what we need. Now t is the thing that is unknown here. All right, F max and r, I know what r is, I know what F max is. Okay, this is for A, F max of A. I need to find what t is. If I find what t is, then I will be able to find the value of mu. So let's look at B now and see if that will help us. If we go to B and resolve perpendicular to the plane, okay, we'll have a similar situation. This force resolved in that direction is going to be 1.6g cosine 50. This is 50 this time. So you can say RB is equal to 1.6g times cosine 50. Okay, so that's going to be 16 cosine 50. 16 cosine 50. So we know RB. And if we resolve the forces down the plane here, because it would go this way if it was going to move, we can resolve the weight down the plane. So that's 1.6g sine 50. Okay, so we have going down the plane is 1.6g sine 50, and that's equal to the tension and plus F max of B. All right, so we need to find what the tension is. We need to find what the tension is in this case. The tension is the same in both parts of the string. Okay, so that's the same. Okay, but the F max of A and B are not the same. Okay, if mu is going to be the same, so we have R. Let's have a look. Let's see if we can do something about this. Let's put in, we know that F max of A is equal to mu R of A. And F max of B is equal to mu times R of B. So this might help us here, okay? So we can say that F max of A is going to, so let's deal with this. We have T equals 12 times sine 40 plus mu times RA, which is 12 cosine 40. Okay, that's F max. Okay, mu times RA. Mu times RA. Okay, so that's from this equation here. Okay, then we have this equation here. We have 1.6g sine 50 equals T plus, and our F max of B is going to be mu times the reaction force at B, which is 16 cosine of 50. Okay, so now we have two equations. We have the same mu, the same T. We can now solve it. I can replace the T here with all of this. Or I can say from this equation, I can say that T is equal to 1.6g sine 50 minus mu times 16 cosine 50. And I can have equation 1 and equation 2, and I can substitute one into the other. So I can say 12 sine 40 plus mu times 12 cosine 40 is equal to 1.6g sine 50 minus mu times 16 cosine 50. I can bring the mu's together. So I have mu times 12 cosine 40 plus mu times 16 cosine 50 equals 1.6g sine 50 minus 12 sine 40. Okay, so this 1.6g, I can just call this 10. It's 16 actually. I can just call this 16. I don't know why I'm doing that. Just call this 16 all the way. That's 16 sine 50. That's 16 sine 50. I can do the same for these two. 16 sine 50. I don't know why I was calling it 16g. It's 1.6g. So 16 sine 50. It's not wrong to do that. I don't need to put the g there once I know it's 10. Okay, so now I can rearrange this. Do I have room here? Yes, I do. So I'm going to take this so that I don't go out of space down here. I'm going to take all of this here and put it on the next page. Okay. It's going to get that with it. I'll cross it off. So pay. Oops, what did I do? Sorry. Take this again. Copy. And come on. What's it doing? 1 second, sorry. I need to copy this. Copy. And paste. Okay. Just get rid of that 16 on top. So now we can take mu as common. We have 12 cosine 40, excuse my writing, plus 16 cosine 50 equals 16 sine 50 minus 12 sine 40. So mu is going to be 16 sine 50 minus 12 sine 40 over 12 cosine 40 plus 16 cosine 50. So that should give us our value of mu. So we have 16 sine 50 minus 12 sine 40 divided by 12 cosine 40 plus 16 cosine 50. Okay, so that will give us 0.23326, 0.23326. So therefore mu is going to be to 3SF 0.233, and there's the answer after all of that work. All right, so here you had to be a bit, cautious here because the F max is not the same in both cases. The reaction force is not the same in both cases, but the mu is the same and the T is the same. Those are the two things that you can keep as the same. Everything else has to be replaced so that you end up with the unknowns T and mu. The question doesn't say find anything else. Good. Sometimes it might say find the tension in the rope, in the string, which then again you'd have to then, once you found mu, find it. Okay, so there we have the answer to question number 5 from October-November 2023, paper 4, variant 1. Other questions from this paper will be found in the playlist that will appear in this region at the end of the video. Other questions from the topic of statics from M1 of Cambridge over here, statics from M1 of Edexcel over there. Just be cautious that they use G as 9.8 there. You can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.